So next we will move on to Goldschmidt geochemical classification of elements based on chemical affinity. So Goldsmith said that elements can be classified into four groups. First one is the siderophiles, means iron loving. So these metal elements have affinity towards iron and present in Earth's core in free state. They have incompletely filled outermost shell. For example, iron, cobalt, nickel, ruthenium, rhodium, palladium, platinum, osmium, iridium, and gold. Next one is chalcophiles. I'm sorry, this will be two actually. Next one is chalcophiles, means sulfide loving. So these metals tend to bind with sulfide and their ions are soft acids. So the soft acid, this thing comes in the hard soft acid base principle, which I will teach you sometime later. So these means these ions are more polarizable in nature and their ions contain 18 electrons in the valence shell. For example, copper, zinc, cadmium, mercury, lead, arsenic, antimony. So just a small, I will just say quickly, just wait 1 second. Yeah, from the hard soft acid base, if I have to say very briefly, you have this atom and you have this atom. Oh, my circles are very bad actually. So if you have two atoms, now in this atom, these electrons are very tightly bound. This atom size is very small and the electrons have stronger affinity towards the nucleus. Whereas in this atom, if this is your nucleus and these electrons are far from the nucleus, the electrons which are here. So what can happen if you give another atom A? Now these electrons or electron density can be polarized, can be changed like this, something like this. So this is just a crude way to say that as these atoms which are far away from the nucleus, they can be polarized or they can be drawn together, they can be deformed. But that thing will be uh, very difficult in these smaller atoms. That's why these smaller atoms are called hard, now hard atoms, and these ones are soft atoms. These bigger atoms are the soft atoms. Now the next one is lithophiles, stone loving. So these metals tend to bind with the oxides. These are hard acids according to the hard soft acid base theory, and their ions contain 8 electrons in the valence shell. For example, alkali metals, alkaline earth metals, early members of transition elements. And next, and the fourth group is the atmophiles or vapor loving. So these elements remain as gas in the atmosphere. For example, nitrogen, oxygen, inert gases. So the thing is, the chemical affinity may depend on environment too. Chromium is lithophilic in crust, but in an oxygen deficient condition, it can exist as a chalcophile. So based upon your atmosphere or environment, your atoms can act differently. Iron is siderophilic in the core but lithophilic in the crust. So different atoms can behave differently according to its environment. Now this is the periodic table which shows Goldsmith's classification based on the chemical affinity, and you can see these blue ones are the atmophile. You can see these inert gases, carbon, nitrogen. These green ones are the lithophile. You can see these alkaline earth metals, alkali metals, alkaline earth metals, some transition metals. These are the lithophiles. These ones are the chalcophiles. You can see here sulfur, selenium, tellurium, arsenic, antimony. These elements are considered as chalcophiles. and these red ones are called siderophile. So you can see iron, cobalt, nickel. So these are called as siderophiles. And some elements can be both siderophile and lithophile. So some element can be both, and depending upon the environment, their nature can also change. Next, we will discuss about the Goldsmith's cosmochemical classification of elements based on cosmic abundance. So cosmochemistry or chemical cosmology is the study of the chemical composition of matter in the universe and the processes that led to those compositions. So according to that, elements are classified into four groups: refractory, moderately volatile, high volatile, and siderophile. So you can see the color coding, and from the color coding, this right hand side you can see the color coding, and from the color coding you can see these red ones, these are highly volatile. These yellow ones are volatile, and these light yellow ones, these are moderately volatile. So for example, these inert gas elements, they are highly volatile. Now if you see fluorine, chlorine, these are volatile, and if you see phosphorus, that is moderately volatile, manganese moderately volatile, copper, gold, these are moderately volatile. Now the green ones, these are moderately refractory, and the blue ones are refractory. So aluminium, silicon, ruthenium, iridium, these are refractory, and this violet one is highly refractory. Tungstenium, osmium, rhenium, zirconium, these are highly refractory. So this is the periodic table which classifies the elements based on their cosmic abundance. So if you want to know more, if you want to know in detail about these things, you can Google these things, or you can see some lectures which are focused on this cosmochemistry.
Hey genius, I hope you liked the video and the concepts are clear. So if you want to know more and if you want to learn more, you can go and check the periodic table and periodic trends folder. I have already uploaded 7 lectures on this topic. Please go and watch all those 7 lectures. I hope it will be very useful for you. And if you think these videos are knowledgeable, please share it with your friends and don't forget to subscribe. Okay? Thank you. Bye bye.